Okay guys, let's work on example 3. It's a little bit different in the fact that this time they gave us a complex root for a solution. So it says if 1 minus 2i is a solution of this polynomial, what are the other solutions? Okay, so complex root. And if you remember, when we have a complex root, we need the conjugate. So they always come in pairs, all right? So they're telling you that x equals 1 minus 2i is a root. Therefore, x equals 1 plus 2i is also a root. So you're just going to have to remember that when you see the complex root, you always have to have the conjugate. They're only going to give you one to try to confuse you, so just watch out for that, okay? So if you look, to explain to you what that means, over here on Desmos, I went ahead and keyed our function in, and you really see nothing until we zoom out some. And the reason it's complex, there's no real solution, because if you notice, it never touches the x-axis. So if I zoom out so that you can see the x-axis, that's why all of the roots are going to be complex, all right? So it really doesn't do us any good to graph it because there are no real roots. So we're basically going to skip that first step to graph and find the real roots, and we're going to start with step 2. So you're going to take the complex root that they gave you, and you're going to do synthetic division with that. So that's going to go in the box. And then we're going to look for placeholders. So you have 4x to the 4th, but we're missing an x to the 3rd. So we need a 0x to the 3rd plus 17x squared plus 14x plus 65. So let's do our coefficients. So you have 4, 0, 17, 14, and 65. So drop the first term down, and what's a little bit different here is that you're going to be distributing. So we've got to multiply this 4 times 1 minus 2i. So 4 times 1 would give us 4, and then 4 times negative 2i is going to be minus 8i. And then you're going to add down. So that's going to give us 4 minus 8i when we add down. So then technically now when I multiply, I'm multiplying 1 minus 2i times 4 minus 8i. I'm going to pull my calculator in for this because we can do this on our calculator to make life a lot easier. So you're going to put 1 minus 2, and to get I on your calculator, it's second decimal. Let me push that up so you can see it. And we're going to multiply that by 4 minus 8 second decimal to get I. Okay. And when you hit enter, it's going to tell you that solution is negative 12 minus 16i. So don't forget, we multiplied here, here, our solution is going to go here. So negative 12 minus 16i. You should be able to add that down. 17 plus negative 12 is going to give us 5, and then minus 16i. But you can even do that part in your calculator if you want. So now we need to multiply 1 minus 2i times 5 minus 16i. So that's going to give us negative 27 minus 26i. I'm going to add that down. So to show you, you could just do 14 plus negative 27 minus 26i. So that's going to give us negative 13 minus 26i. So one more time. So 1 minus 2i times negative 13 minus 26i. And when you do that, you get negative 65. So when we add down, there's our 0 remainder. So we're finished with the first root. We've got to do synthetic one more time. with our conjugate. So 1 plus 2i. And this one's going to be a little bit easier. So when we distribute that, we're going to have 1 times 4 is 4. 2i times 4 is 8i. So now if you look, that negative 8 and that positive 8i are going to cancel out. So we really just have 4 plus 4 is 8. So we're going to distribute again. So 8 times 1 gives us 8. 8 times 2i gives us 16i. So the same thing's going to happen here. The negative 16i and the positive 16 are going to cancel out. 5 plus 8 is going to give us 13. So now when I distribute, 1 times 13 is 13, and 2i times 13 is 26i. So here, negative 13 plus 13 goes away. Negative 26 plus 26 cancels out. So our remainder is 0. You started with x to the 4th. So 4 solutions. We already know 2 of them. Right here are 2. So if that's x to the 4th, this row would have been x to the 3rd. So this creates my quadratic. So 4x squared plus 8x plus 13. And we would set that equal to 0, and we're going to do quadratic formula with that. So a is 4, b is 8, c is 13. So I'm going to come up here for quadratic formula. So we'll have x equals opposite of b, so negative 8 plus or minus the square root, b squared minus 4 times a times c. I'm used to that a being a 1. And then 2 times a. So let's simplify. So under the radical we have 8 squared minus 4 times 13. So that's going to give us negative 144. So then the square root of 144 is 12. The negative is going to come out as I. So we have negative 8 plus or minus 12i over 8. And then you're going to ask yourself, okay, what's the biggest number that will go into 8 and 12? So that's 4. So you're going to say, okay, 8 will go in, or 4 will go into 8 2 times, 4 will go into 12 3 times, and then 4 will go into 8, 2 times, sorry. That's a 2 there, guys. So for your 4 solutions, you have x equals 1 minus 2i, x equals 1 plus 2i, and then x equals negative 2 plus 3i over 2, and x equals negative 2 minus 3i over 2. So here's our 4 solutions to that problem. Okay, so I know the last ones are your turn. I'm going to do that with you one more time just so that you've got the hang of this. We do have another complex root. So 1 minus 6i is a solution. I need a conjugate. Since that's complex, so x equals 1 minus 6i, therefore x has got to equal 1 plus 6i. So again, I don't need to graph this. It's not going to do me any good to graph it. So we're going to go straight to synthetic, and I should have 4 solutions. So we're going to do 1 minus 6i in the box first. Make sure you don't need a placeholder. We don't. So you have 1, negative 6, 74, negative 206, and 1073. 1 comes down. So that's going to leave us negative 5 minus 6i. When we multiply this, again, we're going to have 1 minus 6i times negative 5 minus 6i. So that's going to give me negative 41 plus 24i. So we're going to get 33 plus 24i. I'm going to multiply again. That's going to give me 177 minus 174i. It would help if you stretch this out just a little bit, guys, just for room. So that's negative 29 minus 174i. One more time. So that gives me negative 1073 for my 0 as my remainder. So then you're going to do the conjugate, 1 plus 6i. 1 comes down, so that's 1 plus 6i, which is going to give me negative 4, because the negative and positive is going to cancel out. When I distribute that, I'm going to have negative 4 minus 24i. The i's are going to cancel again. That's going to give me positive 29. So then I'm going to have 29 plus 174i. So all that cancels for 0 as your remainder. So my quadratic is x squared minus 4x plus 29 equals 0. So again, if I could do AC here, I would, but there are no factors of 29 that would give me negative 4. So we're going to do quadratic formula again. So I'm going to come here for our quadratic formula. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c. All that over 2 times a. So we'll have 4 plus or minus. When I do negative 4 squared minus 4 times 29, that's going to give me negative 100 under the radical. So the square root of 100 is 10, and then you take the negative out for I, so that's 10i over 2. So then we can divide both pieces of the numerator, so that's going to be 2 plus or minus 5i when we simplify it. So technically the question said, what are the other solutions? So the other two solutions are right here. But all 4 solutions, I'll box all 4 off. So just be careful what the question's asking you for. So that's how you apply the fundamental theorem of algebra to answer all of your questions.